it will touch the x-axis. Now if it is touching the x-axis, it means there is only one possible value of x, or we can say that there are two roots, but both the roots are equal. So this is the case when the discriminant is equal to 0. And the third possibility is that it is not touching the x-axis. Now this is the possibility when the discriminant is less than 0, or we can say when the roots are imaginary. Because if the roots are imaginary and the imaginary numbers cannot be represented on the real lines, okay, or the real axis here. So these are the three different conditions, and similarly we can plot it here also. When a is less than 0, okay, this is the case when the discriminant is less than 0, this is the case when the discriminant is equal to 0, and the third possibility is, I'll say, like this one, when the discriminant is less than 0. Okay. So these are the graphs of the quadratic equation under the three different cases here. Okay. And when we are discussing the graph, okay, at the same point of time we can discuss how to find out the maximum or the minimum value of the any quadratic equations here. Okay. Because if you look at here, when the graph, okay, whenever the coefficient of a is positive, we always get the graph like this one. And if the graph is like this one, so in that case basically we are getting the minimum value of equation. And the minimum value is this particular point. Okay. And as far as the maximum is here, so maximum can be anything, that is infinity. Because my graph is going like this way. But the minimum value is nothing but like this one. So just by seeing any quadratic equation you can say that whether there exists a maximum value or the minimum value of any quadratic equation. Now here what I can say that since a is greater than 0, so there always exists a minimum value. Okay. And at this point, x is nothing but that is basically minus b by 2a. Okay. So by putting x equal to minus b by 2a in this equation, you can find out what is the maximum value of this, what is the minimum value of this equation. And when the a is less than 0, my graph will be like this one. And when the graph is like this one, we can straight away say that as far as the minimum value is concerned, minimum value it is going downwards, so the graph will be, minimum value is minus infinity, but the maximum value is nothing but that is this particular point. Now at this particular point also the value of x is nothing but minus b by 2a. Okay. So on putting the value of x equal to minus b by 2a here, you can find out what is the maximum value of this quadratic equation. Now when you put x equal to minus b by 2a, you will get the value of y as nothing but that is minus d by 4a. And here also you will get minus d by 4a. Okay. So maximum or minimum of any quadratic equation always exists at x equal to minus b by 2a. Now other things, okay, first thing is that in nature of the roots, then we have discussed the graph of the quadratic equation. Now the next thing is regarding the sum of the roots and the product of the roots. If I say ax square plus bx plus c is equal to 0, then if I say that alpha and beta are the two roots of this quadratic equation. So if alpha and beta are the two roots of this quadratic equation, I can write down that it is nothing but that is basically this quadratic equation is in the form of a into x minus alpha into x minus beta, which is equal to 0. Okay, if alpha and beta. And remember that you cannot write down that if alpha and beta are the roots of this equation, straight away x minus alpha into x minus beta. You always need to multiply by this constant term a. That is extremely important here in this case. Okay. Now, so sum of the root alpha plus beta, you'll always get that is equal to minus b by a, and the product of the root is always equal to c by a, or which is, I can say that is alpha into beta. For example, if I say a question like this one, that if alpha and beta are the roots of this quadratic equation, then find the value of 1 minus alpha into 1 minus beta. Now, again the important thing is here that instead of solving this equation or multiplying this equation and then find out alpha plus beta and alpha minus beta, the important thing is that we have discussed right now that if alpha and beta are the roots of this equation, we can write down that ax square plus bx plus c is nothing but that is equal to a into x minus alpha into x minus beta. And now put 1 x equal to 1 on both the sides. So when you put x equal to 1 on both the sides, you'll get a plus b plus c is equal to a into 1 minus alpha into 1 minus beta. So here we can say that 1 minus alpha into 1 minus beta is nothing but that is equal to a plus b plus c divided by a. So this is the value of 1 minus alpha into 1 minus beta. So never multiply these two terms. Now these are the few of the basic fundas or basic concepts in the quadratic equation. We have discussed right now nature of the roots, then the graphical part, and then the sum of the roots and the product of the roots. And after that we can take a couple of questions based on the quadratic equations here. One more important concept in the quadratic equation, that is, if I say there were two quadratic equations, a1x square plus b1x plus c1 is equal to 0, a2x square plus b2x plus c2 equal to 0. Then what should be the condition for one root to be common among these two equations? So we can say the condition for common roots. Now the condition for common root is nothing but multiply these two. If I remove this particular part, multiply b1 into c2 minus b2 into c1. Okay. Just wait. Not this one, but start from here. Multiply these two first of all. a1 b2 minus b1 a2 into, then multiply these two, b1 c2 minus c1 b2 is equal to a1 c2 minus c1 a2 ka whole square. Now, whenever the two quadratic equations are given, this is the condition for at least one of the root to be common among these two quadratic equations. And once you discuss all these fundas and all these concepts, you can take a couple of examples based on the quadratic equations from the class exercise itself here. Now, after the discussion of linear equations and the quadratic equation, the next thing is